Newton's second law, we say that the acceleration of an object depends on the mass of the object and the amount of force that is applied. So basically, how quickly an object accelerates depends on how big it is and what force was given to it to cause it to move in the first place. Two things when it comes to so first we're going to talk about the mass and then we'll talk about the force. But with mass, the bigger the mass is, um, the less the acceleration is going to be. So if you have an object that is bigger, it makes it harder to get it going. So as acceleration decreases, its mass is going to increase. If the mass is smaller, the acceleration is going to increase because smaller objects, it's easier to get them going, so they accelerate more quickly. So if you think about if you were at the store with an empty shopping cart compared to a full shopping cart, it's a lot easier to, if you had the same exact force, if you push it with the same force, an empty and a full one, that empty one's going to start speeding up a lot more quickly compared to a full one, because the full one has a bigger mass and it's harder to get it going. So bigger mass equals less acceleration. The acceleration when it comes to force, they are proportionally related. So the more force that is put on an object, the more it accelerates. So which is pretty much makes sense. If we look back at the shopping carts, now let's say we have two identical shopping carts, let's say they're both empty. If you push one with 5 newtons of force compared to pushing one with 10 newtons of force, that one to 10 newtons is going to accelerate more because it has more force giving it that motion to begin with. So more force equals more acceleration and vice versa. So, and then another thing to remember is that the acceleration of an object is always going to be in the same direction that the force is applied. So if you push a shopping cart towards the north, it's going to move towards the north. It's not going to obviously move back towards you if you're pushing it away from you. It's always going to go the direction the force is, which again seems pretty common sense. It's something we experience all the time, but it's just to make sure we got that established. Alright, and we do have an equation here for Newton's second law. It's the only equation we have for the Newton's laws, but basically it's showing the relationship between acceleration and force and acceleration and mass. So acceleration equals force over mass, but most of the time people arrange the equation into force equals mass times acceleration. It just is a little easier to work with sometimes. So I'm going to show you one practice problem here just to establish how to use it. Again, it's nothing too difficult here, but just to show you. We're going to use our equation to calculate the force an object hits the ground with based on its acceleration and its mass. So we have a object that is 10 kilograms, which is its mass, and it falls on Earth obviously with Earth's gravity. So Earth's gravity we know is 9.81. So we know force equals mass times acceleration. Now I'm trying to find my pen to write on here, and for some reason my computer is not allowing that. So I would try to put my sloppy handwriting here to show you more, but I'll just talk you through it. So we have force equals mass times acceleration. So mass is 10. The acceleration is 9.81 because it's falling to the Earth, so it's falling with gravity's acceleration. So all we have to do is take mass times acceleration. So we take 10 times 9.81, which would then give us 98.1 newtons, because that's our units on force. So sorry I was not able to write that out. I'm not sure exactly what is happening here with my computer, but hopefully talking it out helped you a little bit with that.